Okay, in this video I'm going to solve the inequality 3 minus 2 times open absolute value x plus 5/3 closed absolute value is greater than or equal to negative 11. Okay, my first step is to go ahead and subtract 3 from both sides. And I have negative 2 times open absolute value x plus 5/3 closed absolute value is greater than or equal to negative 14. Okay, to eliminate this negative 2 times the absolute value, I'm going to divide both sides by negative 2. Now something very important happens when I divide both sides of an inequality by a negative. I got to flip the inequality symbol. So this becomes the open absolute value x plus 5/3 is closed absolute value is less than or equal to positive 7. Notice the inequality switched here because I divided both sides by a negative. Okay, now that I have the absolute value isolated, I can write my two inequalities. The first one's going to be x plus 5/3 is less than or equal to 7. The second inequality is going to be x plus 5/3 is greater than or equal to negative 7. Notice in the second inequality, I changed the sign of the number on the right of the inequality, and I also changed the inequality symbol from a less than or equal to a greater than or equal to. Now, the word that's going to go in between here. When the absolute value is isolated, notice that I have a less than symbol. Less than kind of sounds like and that's the way to remember this. It's not the reason why, but it is a good way of remembering and, less than, and, greater, or. Okay, I've got two options at this point. I can subtract 5/3 from both sides and do 7 minus 5/3, but then I would have to get a common denominator for this over here and work with fractions. It wouldn't be too difficult to do, but there's an easier way. We can eliminate the fraction. So rather than subtracting 5/3 on both sides, I'm going to eliminate this fraction in the inequality by multiplying both sides of the inequality by 3. Okay, so I'm multiplying by 3. I'll need to distribute the 3 on this side, and I end up with 3x plus 5/3 times 3. The 3 simply cancel, and I'm left with 5 is less than or equal to 7 times 3 is 21. Okay, now I subtract 5 on both sides, and I have 3x is less than or equal to 16. 21 minus 5 is 16. Divide both sides by 3, and I have x is less than or equal to 16 over 3. Notice I didn't flip the inequality this time. When I divided both sides by 3, the inequality did not switch because it wasn't a negative 3. Okay, let's go ahead and solve the other one. And you can clear the fraction again by multiplying by 3, but this time I'm going to show you without clearing the fraction what you would need to do. So I subtract 5/3 from both sides. So now I need to do negative 7 minus 5/3, and I have x is greater than or equal to, multiply top and bottom of the fraction negative 7 over 1 by 3 to get a common denominator, and I have negative 21 over 3 minus 5/3. And so negative 21 minus 5 is negative 26. So x is greater than or equal to negative 26 over 3. You'll notice if you're able to work with fractions, there's less steps here. So if you're comfortable with working with adding and subtracting fractions, this is definitely the way to go. Okay, and the word in between here is and. Let's start with the graph. Let's look at what this graph looks like. Okay, we'll put 0 here, and 16 over 3 we'll say is about right here, and negative 26 over 3 is about right here. There's a bar underneath, so I know it's a closed dot at these two places. Less than 16 over 3, well, that's to the left of 16 over 3, and greater than negative 26 over 3, that's to the right, so this is going to come together to form a bar. The set builder notation, since this is an and statement, it's pretty easy to see the set builder notation once you have the graph it's going to be x such that negative 26 over 3 is my lower bound, is less than or equal to, and then I just consider the x, this bar. So negative 26 over 3 is less than or equal to x, and x is less than or equal to the upper bound, 16 over 3. And I just read the verbal to you. The verbal is x is less than or equal to 16 over 3, and x is greater than or equal to negative 26 over 3. So that's what you would write for your verbal. So between the verbal, this is the set builder notation. Set builder. And this is the graph. And of course I've read the verbal to you several times. Okay, that's the solution.